we have multiplication of binomials. Why? Because we have in the first parenthesis 2 terms and in the second parenthesis 2 terms. What we have here? We have the same terms, a square, b square, and different sign. So we can use here difference of two perfect squares formula, if you remember. If not, you have to multiply every term in the first parenthesis by every term in the second parenthesis. So let's use first formula difference of two perfect squares when we have x minus y times x plus y. This is equal x squared minus y squared. In our example, x is equal a squared and y is equal b squared. This formula we can use only when we have the same variables, the same power. So now this is equal. We are on this is our left side, this is equal to x squared minus y squared. So in our example we have a squared b squared, so will be a squared to second power minus b squared to second power. We have power to power, so we have to copy the base a and we have to multiply the powers. 2 times 2 is 4. Negative sign we copy, variable b we copy the base, and again power to power, so 2 times 2 is 4. This was very short way to solve this problem when you know this formula. But if you forgot, you can always do step by step, like I said at the beginning. So every term in the first parenthesis by every term in the second parenthesis, and next we have to combine the like terms. So let me copy our example one more time. Plus, of course, b squared. This is equal every term in the first parenthesis by every term in the second parenthesis. A squared we have to multiply times this whole expression in parentheses. And next we have negative b squared times this whole expression in parentheses. So now we have to use distributive law of multiplication. So we have to distribute a squared over each term in the binomial. So will be a squared times a squared plus a squared times b squared. And next we have to use the same formula. So we have to multiply the same law. We have to multiply every term in the parentheses by negative b squared. So will be negative times positive. When we don't have signs, always positive. So negative times positive give me negative. B squared will be times a squared. Negative times positive, negative. B squared times b squared we have. So this is equal the same base, multiplication we have. So we copy the base and we have to add exponents. 2 plus 2 is 4. Plus, next we have a squared times b squared, so we have to rewrite this expression. And next we have negative b squared and a squared because we have multiplication here, so we can change the order first. We will put a squared because we have a squared here, and always we try to write variables in the alphabetic order. So it will be negative sign and we have a squared b squared minus the same base multiplication we have here, so we copy the base and we add exponents. 2 plus 2 is 4, so this is equal. Now we can combine the like terms, a squared, b squared, a squared, b squared, negative and positive. So this whole term we can cancel out, will be 0. This is like 1 here. And 1 here we have. When we don't have coefficient, it's always invisible 1. So we have positive 1 and negative 1. 1 minus 1 is 0. So this whole expression we can cancel out. What we have only a to 4th power minus b to 4th power. The same what we got at the beginning when we use difference of two perfect squares formula. This is my solution.